Welcome back. The purpose of this video series is to aid you as you prepare to take your final exam. In the resources folder, you will find an entire stack of problems designed to deal with problems from Unit 7 all the way through Unit 12. And what we will do is we'll shoot one video for each unit, hopefully, and we'll take a look at the solutions to the problem. So we're going to lead off with Unit 7. We'll talk about compound interest and present value. I've put the formula on top so we can refer to it as we begin the problem. The first one says Huck Finn's going to deposit 15,000. So that 15,000 represents his present value. And we're asked to find out how much it will generate, how much it will grow into at the end of a fixed period of time. His interest rate is 4% compounded quarterly. So in a year, he'll have 4 compounding periods, n will be 4. Be careful on that exponent. It's 4 then times the 8, or in effect, 32 compounding periods. So again, I'm going to grab a calculator. I'm going to go ahead and divide 0.04 by 4. There's the 0.01. It's easy to add to 1. The rest is calculator gymnastics. You're going to need to raise to a power. So you can punch that straight through in one shot. 15,000 times 1.01 caret to raise to the 32nd power. Hit equals and you're there. And we would have realized that his $15,000 develops into a sum of $20,624.11 at the end of the 8 years. And problem number 1 is officially finished. Time for problem 2. Okay, this one has a 2-part issue where you're going to make an investment and at some point in time, you're going to add to that investment and then you're going to let that grow for a while. So read carefully, and the first investment is going to go for 6 years because it says at the start of year 7. So we're going to calculate the value of that first $8,000 investment for 6 years, compounded semi-annually, so n is 2 compounding periods per year, in effect 4% compounded each half year. So straight plug in 8,000 for P, 0.08 for R. As mentioned, semi-annually makes n 2. The power then is 2 times 6 for 12. Grab your calculator and you'll realize that at the end of 6 years, the $8,000 investment is now worth $12,808.26. What's going to happen is you're going to add money to that. So you're going to take the $12,808.26 and add to it a $10,000 second investment. And you're going to leave that money ride, okay, for 6 more years. So your new investment amount, your new value for P, if you will, is $22,808.26. You're playing with the same interest rates. And again, you're leaving that for 6 more years. So that exponent will still be 2 times 6. There's the 24 for your power. Calculate it all out, and your $22,808.26 over that next span of 6 years will grow into $36,516.76. So at the end of a 12-year period, where the first 6 was just the first investment, the second 6 was the added first investment plus a flat $10,000 extra deposit, grows into $36,516.76. And problem number 2 is officially in the book. Time for problem number 3. All right, Connie's going to lend $25,000 to Beth Ford so she could open her own novelty shop. She's going to repay at the end of 10 years, 6% compounded daily. We're invited to use ordinary interest at 360. So we're taking a $25,000 principal. We're going to find out what it grows into, and that would be the amount that she would then repay her friend at a rate of 6% compounded daily, 360 for ordinary interest. Yeah, ugly calculations on the 0.06 divided by 360. I'm showing you on the screen 0.00016 rep of 10. I should tell you that involved in the calculations, I didn't truncate. I left the full screen display and multiplied that exponentiation where we're raising to the 3600th power and then multiplied by 25,000. And we would find at the end of the 10 years, she would be repaying to her friend $45,550.69. It's a straight through problem where the 25,000 is present value and you're calculating the value at some point in time, the future value for problem number 3. Let's switch answers and bring up 4, and that'll wrap out Unit 7. All right, it's time for problem 4. All right, this time she says, I'm going to need 20,000 for a new roof, and she wants to put some money aside so that in 8 years she'll have enough money to buy the new roof. Her interest rate's 6% compounded semi-annually, and the question basically says, how much does she have to start with so that at the end of that investment period, it amounts to $20,000. So be careful here. The $20,000 is not present value. It's the value at some point in the future. And we'll be finding out how much you need to invest under that interest rate package, under that set of compounding, so that it grows into $20,000. So your unknown is P. Interest rate at 6% compounded semi-annually, thus the 2 for N. Again, your exponent is going to be 2 compounding periods for 8 years, or 16. So the problem for us is to calculate P, we're going to wind up having to divide both sides of that equation by 1.03 to the 16th power. So it's you and your calculator taking 20,000 and dividing by 1.03 to the 16th, and you will find that the principal, or the amount you would have to invest to be able to generate that sum of $20,000, is $12,463.34. So that is your present value of that investment, and that's what you would need to invest under that set of rates and circumstances, so that in 8 years your investment would have grown into a value of $20,000. And that, my friends, wraps out Unit 7. I'll be back soon with a video for Unit 8. See you then.